check forward them.
You threw your notes away. We just took them yesterday.
No. Okay. Luckily, they were just in the trash can by the desk, so it's all good.
All good in the hood.
Because I live in the hood of Rexburg. Okay. So, okay.
I think the first two are pretty straightforward. We were working on them mostly before the internet went out.
Let me go to my math. Okay, so the first few, you can either use the unit circle, or you can use a calculator, but you just have to make sure that it's in radian mode.
Yeah.
So, okay, did you go ahead and do all of it, Connor?
Huh?
Did you go ahead and do the things for the extension problems?
Well, most of them. I didn't really do the last one.
The discussion ones? Or the one in the book?
The one in the book.
Yeah, I didn't either, so that's all good. Okay, so week 7, trigonometry. Okay, so do you guys both know how to use the unit circle?
Yep.
Yeah.
Okay, good deal. Then is there any vocabulary that we don't understand?
Nope, not for me.
Okay. What about for you, Jaden?
Nah, I'm good.
You know, radians, degrees, the difference between them, sine,
Yeah.
cosine, tangent. Okay. What about inverse, like cosine inverse? Are we to that yet?
I don't think so.
Okay, good deal. All right, so let's just run through the answers we got then for number 1.
Okay. For number 1, I got -3, negative square root of 3 over 2. Then I got 0, -1, 1. Oh, I'm sorry, -1, -1, 1/2. Square root of 2 over 2. Then I got 1 over square root of 2, and then negative square root of 3 over 2.
For the sine of -5 pi over 4, I did not get the same thing as you.
No, what did you get?
I got the square root of 2 over 2.
Oh, yeah. You can do it both ways. Sometimes
no, the answer should be the same.
Looks like in the answer key it says that or that. It gives both answers.
What? That doesn't make any sense. How can
Because
it be
like,
2 things?
well, it's just like if they don't want this, a lot of times, like what I saw in mine anyway, is that they don't like, sometimes they don't like to have the radical on the bottom. And so all they did was just simplify it so that the radical is on the top.
Oh, okay. Yeah. I was always taught to never put the radical on the bottom, so I guess that would be why. I was like, no, impossible. Okay.
Yeah.
Then, yeah, I got all the same ones for that. And then negative square root of 3 over 2. Then, did you get 1 for number 2? All of them ended up being 1.
To get what, after you squared them and found the sum?
Yeah.
Yeah.
Okay. Yeah. So why do you think that is, Connor?
Why did I think it added up to 1?
Yeah.
I guess just that's how the math worked out. Because
No.
there's a distance of 1 from the origin to the circle.
Yeah.
Okay.
Since it's the unit circle, any point on that, because the sign is just the, is it the X or the Y? I can't remember now.
The Y, I believe.
Sign is, yeah, sign is the, 1 second, brain. Sign is the X, right?
Sign is the Y, I believe.
Yeah. Okay. Since they're the X and Y coordinates of the point, then it will help you find the radius, because cosine squared plus sine squared equals 1, because y squared plus x squared plus y squared, that is like the equals radius squared. That's the equation for a circle. And since this is the unit circle, the radius is always going to be 1. So when you square both the sine and the cosine then and add them, then it's definitely going to be 1.
Cool.
Which is the radius. Which I think is also just explained in number 3.
Yeah. The compares the Pythagorean theorem with the fundamental theorem.
Mm-hmm.
Cool.
Pythagorean identity.
Identity, yes.
Woohoo. And then it talks about notation, just cosine squared x is not the same as cosine of x squared.
Yeah.
La-di-da. Okay, refer to the chapter in the book corresponding to lesson 2 and guess the formula for motion of a spring and go through the practice problem. Okay, I guess I'll mosey on over to my book then.
I've never opened my book.
Neither have I.
Let's see.
How do you get to the book?
Definitely the money.
I think it's in content. Or it's in my math lab.
I think it's in my math lab.
It's in my math lab. Or at least there's one that says e-text.
Ah, yes.
So I'd assume it's that one. But what if I don't want to get Flash?
What chapter around? Trigonomic identity. No. Around chapter 5.
I think it said to go to chapter 2.
Chapter 2. I thought I said lesson 2.
Oh, lesson 2. Sorry. Yep, it must be 5 then. Or whatever it's in there.
So.
Load.
Okay. So I went up to the search box and I typed in spring.
Oh, did you find it?
Yeah. So I think it's right here.
Ring. Go.
motion of a spring, a weight hanging on a vertical spring is set in motion. Did you guys all find it?
Which one is it?
If you type in spring at the top box, then there should appear like 4 screens. It's the second one, like 1, 2. Like if you're looking at me and I'm the screen, then it's this one
Okay.
at the top on the right.
Okay, I found it.
Except, oh, maybe not. Maybe it's the first one, and then there's a problem corresponding.
I got one for motion of a spring, example 8 on page 359.
Yeah. And we use omega for the constant, which looks like a little W. Okay, the letter omega is a constant that depends on the stiffness of the spring and the amount of weight on the spring. For positive values of x, la di da. A weight on a certain spring is set in motion with an upward velocity of 3 centimeters per second from a position 2 centimeters below equilibrium. Assume that for the spring in weight combination, the constant omega has a value of 1. Write the formula that gives the location of the weight in centimeters as a function of the time in seconds, and find the location of weight 2 seconds after the weight is set in motion. Wow, this is exciting.
Yeah, that's what came to my mind too.
Okay, so let's identify our. Where's my pen? Dadgummit. Where did I put it? Oh, found it. We're good. Okay. Let's just identify the different values that we need. So we have our constant, omega.
Mm-hmm.
That's one. Upward velocity is 3 centimeters per second.
Yeah.
Oh, that says 4 centimeters.
And since it's upward velocity, would that make it -3?
Upward velocity. That seems like it'd be going positive, but I see they do have like initial velocity being -3.
Yeah, I think since I don't know why it's negative.
Okay, just make sure I'm on the right one. We're on the one that says 88, right?
Example 8.
Oh, example. Okay, where am I?
Poor Jaden, he's like, it's what the heck? It should be on page 359.
That's the page. Wait, 359?
Yes, sir.
Yeah, you can just type it into the page box.
I clicked on the wrong one apparently. Oh great, and now it took me out of the textbook.
Well, that's no good.
What page? 359?
359.
Okay, because I was like, it says there's an initial upward velocity of 4 centimeters. What are you talking about? Okay, I found it.
Okay, so. Ooh, so many tabs. All right.
Okay.
I don't know why it's negative. Do you know why it's negative?
I don't either. No, I don't.
Because it just kind of feels like being negative.
Yeah.
It's having a bad day.
It's not really. Okay.
But
So
it's okay. That's how it is.
if you go back one page, it gives you the equation.
Mm.
So it's x equals initial velocity over omega sine omega time plus initial x cosine omega time. Oh, and then it has a spring, and if it's upward motion, if the weight goes up, then it's a negative, and if it's downward motion, then it's positive. That's why.
Okie dokie.
Just because that's how they measure it. Okay. Good to know. Okay, so our initial position, or x initial, is going to be 2
2 centimeters.
below the equilibrium. Okay, so write the formula that gives the location of the weight centimeter and 2 seconds after the weight is set in motion. Okay. So
For velocity.
X
Okay, so
equals -3/1, so just -3 sine of t
1 times t.
plus initial x, so plus t cosine of t.
I mean, if it's 2 seconds, we can just plug in 2 for all the t's.
Yeah. Okay. And then it's a really ugly answer.
What did you get for your answer?
-3.560185954.
Cool. Yep. Okay.
Yeah. Okay, so I think that's everything for the first one.
Yep, that looks good
So
to me.
let's move on to the second one.
Yeah. Do we need to pause and submit it separately, or can we just say that the two things are included in one?
Yeah, I think we can just do one. I think that'll be easier.
All right.
Perfect.
Okay, so now close that. So, shall we do the quiz first?
I think we shall.
It would be the smart thing to do.
Okay, group quiz.
We are smart people, so that makes sense for us to do. What?
No, Susan, you're the smart person in our group.
Is that a typo? A glad pod? Yeah, it should work in a washing machine.
No, it's game pod.
Whoa. Yeah, the game pod. You just throw it in there.
I know. Sometimes though they won't dissolve because it needs to be like a
Hot temperature?
What?
Does it need to have warm water?
No. It just sometimes, like, depending on the washing machine, it will dissolve in all.
Technically, they do dissolve better in warm water.
Because technically they dissolve better in warm water.
I prefer scalding water, but
Obviously, they dissolve better in warm water, but in washing colors.
She's washing colors, so she can't put it in warm water.
We're gonna try it.
Of course you can. You just end up with tie-dye.
Off the pod. Okay. Sorry, guys.
no worries. Okay, let's list all the transformations.
That's my favorite thing to do. Not really.
No.
I don't like listing transformations. Wow. this is great because I have no clue what I'm looking at. Okay.
So would amplitude be considered a transformation?
Oh. I was like, so it's going right, see? Okay, I will look at this graph. It's kind of tiny though. There we go. I made it really huge. Now I should be able to see it. Okay, so with a cosine parent function, that it's supposed to start at 1, right? Which means this one has been shifted.
Yeah. Looks like a sine function now, kind of.
Yeah, but it didn't actually start at 0, so it's all a lie.
Yeah.
Well, we just need to see where it's 1, or I guess where it reaches a peak, and that's at 5. So, first of all, there's a vertical stretch of 5. So 5 cosine.
That's our. Would that be considered our amplitude then?
Amplitude, yep. I just like saying that word.
Amplitude.
And then the periods for this are supposed to be like 1 full, or like, you know what I mean? Like there should be 4 periods within
Right.
2 pi. No.
Would it be? That's at what? 3 pi halves? The peak is? Is that right?
The peak, yeah, I think it is. And it's supposed to be, yeah, 1 period is supposed to be from 0 to 2 pi. So this one has been stretched a lot.
Yeah. So we yeah, I'm kind of stuck on the because right now we're trying to figure out what B or the period is, right?
Yeah.
Okay. Isn't that something like where? I don't know.
Okay, I'm going to amend my initial statement that it has been increased by 5 because it's actually just been moved up to 2
Yeah.
and increased by 3.
Good point. So the stretch was actually. Wait. So what was the stretch then? What was the
So
amplitude?
the stretch was 3 and it was just moved up to 2.
Okay, so D is going to be 2, and then A is going to be 3.
And A is going to be 3. And then B, what is B? Is that the horizontal stretch? Because there is one of, let's see.
It should go to just 2 pi.
Yeah.
Stretched by a whole pi.
Yeah, it's stretched by 2 pi. Well, okay, so in the parent function, which is just like cosine of y equals cosine x, right?
Y equals cosine x, yeah.
So then let's see, 1, 2, 3, 4. Pi over 2 is implied as the b, or it is the b. So if it's already pi over 2 and then it becomes 2 pi, then is that going to be 2 pi or is it going to be 4? I'm not sure.
Okay, so you're saying the period already, so the B should be 2 pi, but since it's been stretched by 2 pi, you're saying it might be 2 pi over pi? Or 4 pi?
So what I'm saying is that since in the parent function, 1/4 of the period is pi over 2, and now 1/4 of the period is 2 pi, and pi over 2 isn't written in the initial, then I don't know that you would write 2 pi as b.
Okay.
Do you know what I'm saying? Yeah.
I think kinda. Okay, let's see. Google. Yes, one period is 2 pi. But now it goes all the way out to what is that 3 pi? So has it been stretched by 2 pi or just 1 pi? The horizontal stretch.
I'm not sure.
Because now it looks like it's going all the way out to 3 pi. So it looks like it's just one more pi.
Yeah. Up to.
Any ideas, Jaden? Nice.
Nope.
Okay, so I know for sure that b is not 4.
Okay.
So that's exciting. At least I don't think. Gummit. Two pi equals what? Like 6?
Ish.
6, I mean. Approximately. So yeah, let's see if I do 1, 4. I think it's stretched by 1/4. No. 1/2. Okay, I don't remember. Okay, there's a way
Yeah, there's a
to
way to.
calculate the b, and I can't remember it.
Yeah, I know it sounds familiar too. It's I made a note of it somewhere.
So, what is our c? Is it 3? I can figure that out while we're pondering b.
Oh. Okay, I think. Did we just take out the Can we just multiply out the c value? No.
Okay, so our period is going to be 2 pi times 4, right? So 8 pi.
2 pi times. Okay, yeah. So where did you get the 4 though? I believe you. I just don't understand.
Okay, so I got the 4 because one peak, or like from pi over 2 to 5 pi over 2, which is where like, okay, so you know how it goes up and down over a line? That line is at y equals 2. And so I just went from where it crosses y equals 2 to where it crosses y equals 2 again. And that is going to be 1/4 of the period, because that's how cosine functions are. So if 1/4 of the period is 2 pi,
Oh, yeah.
then the period is going to be 8 pi, right?
Okay.
All right.
And then 8 pi is equal to 2 pi over 1/4, right?
8 pi is equal. You said 8 pi is equal to 2 pi over 1/4.
Yeah, because 2 pi over 1/4 you would multiply by 4.
So how do we
Okay,
write?
so in a
how are-
function, the way
How
you
are we
calculate.
writing it in here?
Okay, so I'll tell you why I'm doing this. In a function, the way you calculate b is you find the period,
Mm-hmm.
and then you just set that equal to 2 pi over whatever makes that period true. So if we have 8 pi, that equals 2 pi over 1/4, which means b is going to be 1/4.
Right. So like that.
8 pi, not 2 pi, because the
8.
period is 8 pi. 2 pi is just 1/4 of the period.
8 pi. Okay.
So that means we can, no, we know that b is 1/4 of x minus what is c? What is c? So this go down to,
And then did it get slid over at all? Well, it got pushed over by 3.
3. Yeah, that's what I see. So it's minus 3. So plus 2, and then plus 2 at the end.
And plus 2, yeah.
So I got x equals 3 cosine of 1/4 x minus 3 plus 2.
That's what I have.
Okay.
And then we gotta state the range as well. So that'd be what, -1 to 5?
The range? Why would that be -1 to 5?
Yeah. Now is that
Yeah.
inclusive or
Oh,
not?
yeah, the range. Sorry. I was
And
thinking
that's
domain and I was like, you crazy.
oh.
Yeah. So,
Is that-
yeah, it would be inclusive. It'd be -1
Okay.
to 5 inclusive.
Cool. Okay.
Okay. That was so fun.
Oodles.
Yeah. Fun.
Oh, okay.
Okay.
These ones.
Find sine of, I forgot how you call that. Is that
Alpha.
alpha? Yep. I was like trying to remember the Greek letter. Okay. Find sine of alpha given that cosine alpha is 2/5 and sine of alpha is less than 0.
So we'll be using the Pythagorean identity, right?
Yes. So we know that sine of alpha, sine squared of alpha plus 2/5 squared is going to equal 1. And then we know that it's going to be negative, even though it's squared. So just do 2/5 squared. That's really easy. It's just going to be 4/25. So then 1 minus 4/25 is going to be 21, negative 21
Yeah.
25. Oh no,
So-
1 minus 4/25 is going to be 21/25.
Yeah, positive, right?
Yeah.
So then that should give us
And then we just, square
21 over
root that.
5. Yeah.
So that can be broken down into square root of 21 over the square root of 25.
Which we could just simplify down to 5, right? Wait.
Yeah. So square root 21 over 5.
Yeah.
And then
Could you simplify the 21 to 7 or no?
no, because that's 7 times 3, and this is a square root.
Okay,
So 7 times 7 is 49.
that's a good point.
So, and 21 is, yeah.
And
so
then since
that's
it's
just,
less than 0, it's
negative.
negative.
yeah. So it's just going to be negative square root 21 over 5.
Cool.
And if we want, we can plug that back in and see if it actually equals 1, just to make sure.
I'll do that as well. And then I'll do that after we finish up here. But
Okay.
then we have, or I can do it now if you guys want to wait a second. Either way is fine with me. So.
No, let's just go ahead and finish. This is
Okay.
almost done. We're almost done. Use the fundamental identity to write two functions for cosine A in terms of sine A. Indicate which formula to use for the given value of alpha. Okay. So we have our original, which is sine squared of x plus cosine squared of x equals 1. So we're putting it in terms of sine A cosine of alpha. Okay, I guess we can put alpha instead of x. So we're just going to isolate cosine A. So 1 minus sine squared of alpha. But then do we have to do the square root of all of that?
I think so.
Yeah.
So and just to clarify, we're isolating sine alpha?
We're isolating cosine alpha
Cosine alpha, okay.
in terms of sine A. So sine alpha is going to be on the other side. So we square root both sides. La-di-da. And then cosine alpha is equal to 1 minus sine. Oh wait, no.
Would it be because
Okay.
if we square rooted the sine, squared alpha, would that just make it sine alpha?
Since it's 1 minus sine square of alpha and not times, we can't just do the square root right off.
Okay.
You know what I'm saying?
Yeah.
So we have to leave the square root.
So would it? Because it looks like we just leave it as is then with the square root over it on the right side, right?
Yeah, but I feel like there's a way to. A way to.
What if we did it? What if we did it before we put over the instead of before we moved the sign squared alpha to the other side? What if we square rooted that and then did it?
It's still addition.
Oh, you're right. It's still addition. Okay. But I mean, because we could write it just as in both. If we square rooted sine squared alpha plus cosine squared alpha, we could just write it square root of sine squared alpha plus square root of cosine squared alpha. Does that make sense? I might be completely wrong here. I'm just trying to think it through.
Let me see. So let me think in my brain. So what is cosine? Sine, okay. Well, I have the cosine identities memorized. I
Okay.
don't know if I can just write those down.
Oh, so you know what it should become then.
Yeah. But there are a bunch of different ones. There are more than two. So there's like cosine equals sine of pi over 2 minus angle. But I don't know if that's what we're looking for here.
Sine. Shoot. Okay. We want to write two functions for cosine A in terms of sine alpha. Okay. Well, so what are we trying to get to? Or what's one of the options we're trying to get to?
So I think it's cosine of alpha equals just plus or minus the square root of 1 minus sine squared alpha. But like I can't remember if you go farther than that.
Let's see. I feel I seen the one. We somehow make it like. I know cosine of alpha can equal 1 over secant of alpha, right?
Yeah.
Can we make this into that? Because that's just 1 over sine, right?
Yeah, so secant is 1 over sine.
So there's some way we could do that here.
What is going on with my brain? Let's see.
Look at my notes here. What if we did? Ugh, I don't know.
Okay.
What if we? Well, it says we have to write 2 of these too. So what would be the second one?
Plus or minus.
Oh, I see. Yeah, that's a good point. Yeah. Um,
I know the half angle identity thing.
well, this is fun.
Yeah.
I don't see what else we could do, honestly, because even if we did do it the way I was talking about, we'd still just get. I don't think it'd do much.
Yeah.
What does it mean when it says indicate which formula to use for a given value of alpha?
So given value of alpha, like maybe greater than 0, less than 0?
Yeah, that is crystal clear instructions right there.
I think it probably makes sense if we know what we're doing.
Yeah, probably.
Use the fundamental identity. In terms of...
Well,
Okay, I'm just gonna say we should leave it as cosine alpha equals the square root of 1 minus sine squared alpha. Because it's not like it's unheard of for formulas to have a square root, because that's what's in the quadratic formula.
Yeah.
that's true. Okay, that's fine with me. I mean,
And it's going to be plus or minus.
plus or yeah, so it should look like this.
Ooh. Okay, cosine x equals plus or minus square root of 1 minus sine squared alpha. Yep.
Cool. All right.
All right. And technically that is two functions.
Technically, it is.
Plus or minus.
Yeah. I don't
Nice
know.
I checked the number 2 and it works out, so we're good there too.
Okay. Sweet.
Okay. Do you guys have anything else you wanted to go over before we wrap it up? Was there anything like in the prep or other stuff you wanted?
Just indicate which formula to use for a given value of alpha.
Oh yeah.
So I think when let's see.
I don't understand what that means. So I don't know what it's asking there. Would we just say the Pythagorean identity?
No, I think so. You use the positive one for when alpha is positive. Because whenever you square things and square root them, it gets rid of the positive and negative. So I think you use the positive formula for when alpha is positive and the negative formula for when alpha is negative. Just like in the first one, I would said sine of alpha is less than 0.
Yeah.
Yeah. So use positive formula when alpha is positive.
Yeah, I think so. If not, then we tried, and it's better than nothing.
Yeah.
Okay. Added that there.
Okay. Is there anything anyone else wants to go over?
I think I'm good.
Yeah, I think I'm good too, honestly.
Okay, then let's just turn it in. And
All
that will
right.
be 50 minutes, so record time. And we did 2.
That is record time.
What a mess.
Okay. I'll see you guys Tuesday.
All right.
All right.
All right.
All right. See you.